The outputs of PLCs. The output of a PLC is basically a switching device, not necessarily a switch, that connects to connecting screws, which is controlled by the PLC itself. So the PLC has an internal program that will control the value of the Q. That Q will then connect to a coil. That side connects to the 0 volt, or that Q will connect to a base of a transistor. Now, when Q switches on, when Q goes on, then technically what happens, it has a positive supply voltage connected to it. As a result, if it's a coil or a high current PLC on the output, it will allow for conduction to take place through the coil, which allows the coil to become magnetized. If it is a transistor or a low current output PLC, if we connect a positive on the base of this transistor, that transistor will allow it to become conductive. Now, on the output side, or on the external side of the PLC, if it is a switch model or a high current model, we will have that an actual switch that is mechanically or electromagnetically connected to the coil. So if the coil becomes energized, that switch closes. If the coil de-energizes, that switch will open. Those 2 points over there are then wired to connecting screws for external connection. On the low voltage or low current electronic switchgear, we will have the same configuration which connects to our connection screws. Conversely, we can have the electronic switchgear which uses a thyristor. Thyristor configuration is exactly the same as my transistor electronic switchgear, whereby Q will connect to my thyristor, and then those connecting points will connect to the external circuitry. In all of these, we will have the same effect of a voltage connected onto the Q will allow for conduction through terminal 1 and 2 on all 3 switching type or switch gears. With reference to contactors, PLC needs to control devices. Now, the PLC might be a low or a high voltage device. If it is a high voltage device, then the output will be able to directly connect to the PLC. Okay, so we will have our live connection, which will connect into our PLC's Q terminal 1 and Q2's terminal 1. Then from terminal 2 we will then connect onto our contactor on both terminal 1 and terminal 2, which will then in turn connect to neutral. These contactors will control a motor or something in that respect. When it comes to the relay or the low voltage output, remember these outputs are based on our transistor or thyristor configuration. These devices cannot handle excessive currents, and as a result they are typically low voltage devices. So for a PLC with a low voltage output, that PLC will have Q1s, terminal 1 and 2, and Q2s, terminal 1 and 2. And terminal 1s will connect to the positive supply voltage. And then terminal 2s will connect to an external relay that has the ability to then connect our contactors between live and neutral. That there will connect to my, no, that's wrong. Those there will connect to my 0 volts on that side, and that will connect to my switch that connects to the contactor, which connects to neutral over there. And then, sorry for that mess over there, but each contactor connects individually to a relay. Each contactor connects individually to a relay, and the relay is controlled by the Q outputs of the device. These relays, then the switch side will connect to my live in order to supply my contactors with high power. If we're using low voltage contactors, we can replace combine the low voltage PLC with the low voltage contactors.